So let us just quickly get started with NumPy. Now NumPy is a package in Python which is used for computing scientific and mathematical data. Now it allows the creation of a multi-dimensional homogeneous arrays, but Python also do has a list. So the major advantages of over using a NumPy array over Python list is not only that it provides a lot more functionality in sense of the functions available to be applied on those arrays, but also it's a hell lot more quicker and also saves a lot more space. So let us just quickly dive into this basic tutorial on how to use NumPy. Now I'm using an Anaconda package here which does come with NumPy. In case you're not using Anaconda, you do not have NumPy, you can install it using pip by issuing command pip install NumPy. So let us, as NumPy is a package, to use any package in Python or any other programming language, we need to import it first. We say import NumPy. NumPy is NP, that is an alias most commonly used, so we'll use that only. Now as it's told, it allows the creation of a multi-dimensional homogeneous array. Before creating a NumPy array, let us see how a Python list is created. So we say x equals, it's very simple. Now this simply allows the creation of any Python list. So this is a Python list for us. To create a NumPy arrays, we're going to use something called, from this particular list, that is, we're going to use something called np.arrays array. To create that, we say a equals np.array, inside of which you're going to be passing an array, a list that is going to use to make a NumPy array. In our case, as I said, we're going to simply use x. So we say x, and it will create a NumPy array. As you can see here, if I write down a, it prints out array. We can also be confirmed it by writing type a, and it should give out the NumPy array, which it did. Let's see what type of x was. So type x give us out that it's a list. So now we're going to look at something called a range function. Now Python does have a range function. Let's see how that works. So if you say b range 0 to 10, right? And if we say b of 5, it should print out 6 because the index starts from 0. So it print out 5 because 0 would be 1. Okay, we use range 0 to 10. So b5 is 5 in fact, because b0 is 0 and b1 is 1. So b5 is 5. To see what the last element is, we say b minus 1, and it does 9 because this is the upper bound. This value is not inside the range function, it's the upper bound. So similarly, there's an a range function. In our case, we wrote 1, 2, 3, 4, but what if we wanted to create a NumPy array containing, let's say, 100 numbers? So there's an a range. So we say a equals np dot a range, and we want to start our range from, let's say, 1 to maybe 10. So it does the same thing. So if you write down a, so it created then NumPy array from 1 to 9 because 10 is not included, 10 is an upper bound, right? And indexing them is similar to what we did right here. So a of 1 would be 2 because indexes starts from 0. So indexes starts from 0, so you can see a of 0 is in fact would be 1, and to index the last element we say a of minus 1, that would be 9. That would be 9, right? So apart from this, okay, there's also, you can use steps, which would be np dot a range, that will be the third argument to this a range function, 1 comma 10. It is commonly called steps because this will be the difference between two consecutive numbers. In our case, we didn't provide it anyone here, so 1, 2, 3, 4. But what if we provided a range step of 2? So after 1, a step of 2 would give 3, 3, and a step of 2 would give 5. So let's see if we print out all the odd numbers. So let us put sheet here. So 1, 3, 5, 7, 9. Now the 2 to 10 is not included, so 1, 3, 5, 7, 9. Similarly, it provides a lot more function NumPy. So there's something called a min, which prints out the minimum of that number. There's a max, which prints out the maximum of those number. So there's a sum, right? So a sum would this time be 25 because it is a sum of these numbers. So you can just simply add and figure out what is the sum of these numbers. Similarly to a range, there is linspace, not in fact similarly, quite different, but a equals, or let's say just simply do np.linspace. np.linspace, okay? So in an a range function, what it did was it made us an array computing of these number between 1 and 10, and at max you could have a step of 2. But what if you wanted to have at least, say, let's say you wanted to have 30 numbers between 1 and 10, okay? And in this case, unlike arange function, both the lower bound and the upper bound are included. So let's see what it does. So you see, okay, so there are 30 numbers that have been created, and they are all actually have the same differences between two consecutive numbers. So they are all linear, right? So there are same difference between each number. They are equidistant to each other. So it created. This is the range that you want to create those number in, and this is the number of element you want inside this range. So now because I told you that we use NumPy to create a multi-dimensional arrays. So now we'll get started with multi-dimensional array, which is quite similar to any other multi-dimensional array to create. Right, np.array and parentheses. Okay, what I'm missing. We'll create a multi-dimensional array. Let's say 1, 2, 2, 3, and let's say 4, 5. 4, 5, right? And now that we print it here, so as you can see, we created a multi-dimensional array. So let us see what is the shape of the array. Shape means what is the number of rows and number of columns. In this case, we see that there are now 3 rows. There is 1, 2, 3, and there are 2 columns. So a.shape should give us number of rows into number of columns. That is 3 by 2. Let's see what it does. Okay. Oh my god, it's tuple. Object is not callable. A.shape. Right, so it gives us 3, 2. So there's also reshape, that is you can reshape this to any other shape, but that should be compatible. Now what compatibility means here is that you can see the number of elements here is 6. So what should be the product of rows and columns should be 6. So there's 1, 6 that is compatible, 6, 1, 2, 3, 3, 2. And any other number should throw us an error. So first just quickly just see, okay, 3, 2 is same, so we're going to say 2, 3. So if we do 2, 3, it will reshape this array. You can see here there's a difference. Now there are 2 rows and 3 columns. Now I told you any other non-compatible number will throw us an error, which we are going to see here. Let's say 3, 4, and it should throw us an error here, which it does. It says cannot reshape array of size 6 into shape 3, 4. Size 6 basically means that there are 6 elements in this array. Now let us see a few other functions that NumPy provides for the creation of these particular type of arrays. The first one would be zeros. What if you wanted to create a NumPy array of a given of your desired shape, but all the elements should be 0? Writing it down, let's say you wanted to create 30, but writing these down would be a hectic task. So NumPy has something called zeros. So you can say np.zeros. The first argument is the shape. In fact, there's only one argument, that is the shape. So we say 2, 2, and it made a array of shape 2 by 2, and that each element is a 0. Similarly, there's a function for 1. What if you wanted to create an array that contains 1 only? So that's np.ones. So np.ones 2, 2 again. Let me just write down the shape 2, 2. So as you could see that it created us an array of shape 2, 2 in which each element is a 1. So now that we are done with zeros and ones, what if you wanted to create a NumPy array similar to the one you're creating with ones and 0, but with your own constant number? That is, let's say you wanted to create an array of size 2 by 2, but you wanted to have some number, say let's say 4 or 14, 15, any number. So NumPy does provide a function for that, and it's called mp.full. So it would just be 2 by 2 because you are creating 2 by 2, or you can take any other. For a change, let's take any other size. Let's say 3, 3 or 3, 4, and let's say we want that constant to be 5. Now it did create, let's say 3 rows, 4 columns, and the constant number here is 5. There's also something called an identity matrix. I hope you know what that is. In an identity matrix, only a diagonal number is 1 and every other number is 0. To create an identity matrix, NumPy provide a function called d.np.ice. So we say d equals, you can to store it because we'll do some operation on it. Now d.np.i, and because as I told you, it creates a diagonal number 1 and the number is 0. The one of the major what you say properties of identity matrix is that it's a homogeneous, sorry, square matrix. So square matrix essentially means that a number of rows equals number of columns. So we do not need to provide a shape like 2 by 2, 2 into 2, 3 into 3 into 3 like that. We can just give one number and it will be understood that it's a home because it's a square matrix. The shape will be 3 by 3. So we say D, we print it out, and this is how an identity matrix looks like. Now this we can do some more operations like we can add two matrices, and that addition is very direct. So for addition, the let us create this. The shape of the matrix should be same. So np dot not arrange np dot arrays, or maybe let's say ones. I'm going to fill it with full or one. Let's say full, and we're going to create it with a shape similar to the one that we have with identity here, 3 by 3. Let's say 6, right? So let's say what a looks like now. So a looks like this now. So now we can do direct addition between two matrices, a plus what was our identity matrix g, and let's see what it does. So we do an addition on this matrix, so we can see that there was 1 on diagonal and this was 6 everywhere. So on diagonal we got 7 7 7, that is, the addition was successful. There's also something called dot products. So one of the features of an identity matrix is that whatever matrix that you multiply with that identity matrix, the result is the matrix itself. So we're going to see that is a dot, and that would be D, sorry, what was D, okay, our identity matrix is D. So we say D, and as I told you that whatever matrix you multiply with an identity matrix, the result is the matrix itself. So this is here proven. The next thing we are going to do is we are going to stack them. So what if you wanted to stack a matrix? Stack means you wanted to, let's say, arrange a matrix such that after this part, the next part would be this. I mean, if you stack one over another, that is called vertical stack. But if you want to stack in terms of, let's say, left, right, that would be our horizontal stack. So let's see our vertical stack first, but both are very similar, nothing different between them. So let us say E equals, because we are going to do something called split afterwards. So we're going to store this V stack. And now we mention the order in which we are going to stack. So we wanted our, let's say, A to be above, and then we want our D. It's D, right? Yes, it's D. So we're going to print that, and let's see it stacked it. Similarly, there's a horizontal stack, so we can say np.h stack, and similar to that, it also takes the order in which we want to stack, and we say AD, and it did print, it will horizontally stack. Similar to stack, if you wanted to split it, so there's something called split, so we say np dot split, and that is why I stored this v stack somewhere. So what it takes is, it takes the array to be split and the number of splits to be done, right? If now you have to make sure that the number of, now what you have to, the number you give, you have to make sure that the split it does are all equal. You cannot give it a number such that it cannot divide it equally. So because in our case you can see that it's we are going to split it, it is going to be a vertical split, so we need to mention vertical split. Now e comma 2, it will give back our original A and D. So as you could see, it did give us A and D. This is A, this is the first array, and this is the second array. It's split into two parts. But what if I told you that it will, as I told you that it will give error if you try to split it in a way that it's not homogeneous. So let's see np.h is, or sorry, v split, np.v split E, and let's see what was this. This is 1 2 3 4 5 6. Okay, 4 would be the right number to give us an error, and this would actually be E and not 3. And now we did, and it did give us an error. The last error says array split does not result in equal division. So it has to be, you have to give a number such that the division result in an equal way, right? So now similarly you can do H split is very similar, so I won't talk about that. We have done zeros, we have done ones, there's something called random. So what if we wanted to create an array that is filled with random numbers? So we're going to say equals np dot random, and the only argument that it takes is the shape of the array. So we say 3 comma 4, and we try to print the e, and it is filled with random values. The next time, to make sure it is random, you take this, and the next time we'll do this, it will be different. Just see np dot random, and the shape is 3 comma 4. So this time it will be different than the last time. It's almost like impossible that you'll get like the same values for each time. Let's see this e, and if you can see that they are two very different arrays. So these are random values. So now that we have talked about different kind of possible NumPy, how to create NumPy array, some operations like a plus b, a plus t, something, a max, a min. Okay, a max, a min. So there's something also, you can also do something like square root, standard deviation. To do square root, do say np.sqrt, and you'll pass down the array you want, sorry, a NumPy array that you want to make a square root of. Let's say in our case, e, not sure e, do not see that very carefully. Let me use some other array. Okay, let me use a itself. What was a? A was 666. So that was, so let me use a. So you can see that the square root of 6 would be this. I think you can use calculator Google to find out. The reason I didn't really use e was because there's a property that says that when you square root a number between 0 and 1, the square root of the number is greater than the number itself. So you can try that out here. So if you do np.sqrt and we can see that the number, because every number is between 0 and 1 and 0 and 1, each number value is greater than the number itself. You can figure that out on graph. Even in the graph you could see this happening. So now that we've got most of the basics part, I think we are done with the basics of a NumPy. But let us see some other things. Let us see how to print maybe size. So it's very simple. We say e.size, and it will give us the size of our, size means the number of element in our NumPy array. It printed out 12. So let us see 3. Where is e first? I need to figure out where is e. Okay, e would be this. So you can see 1, 2, 3, 4, 8, 12. So the size is 12. There's something called n bytes. So let's see what n byte is. So n bytes would print out 96. Now before n bytes, it's my fault. I should have used something called ItemSize and size and type. So let us see what ItemSize print, and then you'll understand what n byte meant. ItemSize. Okay. Now ItemSize is 8, which means 8 bytes. And why it's 8 byte? Let us see why it's 8 byte. So e.dtype. It should be int64 to be yes. It's float 64, size of which is again 8 bytes. So, and they are 12 size. So the number total byte would be 96. 12 into 8 is 96. Next thing, you could see the dimension, because the 2 dimension should print 2. e.enddim would print out the dimension in your NumPy array. And it's a 2-dimensional array because there is row and column that is correspond to the dimension. Next thing could be slicing, but so slicing. So what if you wanted to slice your array? Slicing is pretty much similar to the one you use in your NumPy arrays. So sorry, your Python list. So let us create a simple one-dimensional to start off with. That would be np.arange between 0 to 10, and it did create x. Let's see what x is. And now it's very similar. Let's say you wanted to slice between the first element, that is the 0th index, to let's say the 5th element, that is the 4th index. And once you do that, this is out the output. To get the last output, you say -1 to print out each element. Just simply do this. So slicing is pretty much similar. So one thing I forgot was the multidimensional split. So let us create a multidimensional array really quick. So np.array, and we're going to create a multidimensional array here. 1, 2, 3, 4, 5, 6, and one more columns, one more row, 7, 8, 9. This is our multi-dimensional array, and we'll see how it looks like. So this is our multi-dimensional array. So slicing is very easy, in fact very similar to that one. So you have to just take care of both the actually row and column 2 dimensions. So what if we wanted to have all the rows and all the data except the last column data? So this is how you will do it. So where is it? So we print out X, we simply see that we got all the rows except the last column data. To select all the rows, sorry, so select just the last column data, we do something called X equals E, and we'll do -1. This should print out only the last column. So we'll see X. So they did print out the last column only. So slicing is very easy. Slicing is actually very same to how you do on Python list. Nothing different. So I guess this is what is in the very basics of the NumPy. This is the very basics of NumPy. Of course, there's lot more to cover if you got into deep, but this should just get you started.